Welcome back to the Home Lab, and I've got a really interesting build demonstration explanation for you today. What we're going to look at is the science of tensegrity, and I'm going to build a table that doesn't need any legs at all to stand up. Over the past year or so, my son's been showing a real interest in space and space technology, and particularly the space shuttle. So I bought him a little kit and we built it. And it was only after building it I realised that the interesting bit is not the space shuttle, it was for him, but in fact this rather unusual stand, which didn't get any really special mention in the instructions, but it's really clever. It uses the science of tensegrity, which was invented by Richard Buckminster-Fuller. You might have heard of Buckminster-Fullerene or buckyballs. And it consists of only wires, you can see the beads on them here, that are acting in tension. So for this top bit to stand up, there aren't any bars going down vertically in compression. You might have actually seen these things before, because Buckminster-Fuller was really interested in structures that could be very quickly built and put up, houses and things like that. And Barry, when he was younger, he wasn't particularly interested in it because it didn't do an awful lot. I was, because this uses the same tensegrity technique. So we've got sort of wires or ropes that are pulling sort of inwards, and they're being pushed away, so there's tension and compression in equal measures there. And we've got these bars as well holding it together. So it's quite an interesting structure. So today what I'm going to do is I'm going to build a bigger version of this. I'm going to build a table that stands up using tensegrity ideas, but not having any supporting legs at all. But just before we start, I want to say a huge thank you to all of you again for supporting my little channel and leaving some absolutely fantastic comments, and I hope that I've answered all of them. Also, again, to PCBWay for just letting me do whatever I want to do and supporting my videos. As you know, they're well known for printed circuit boards and CNC machining, but they also do 3D printing. And this project, I think if you built a smaller version of what I'm building today, I think would lend itself to 3D printing very well. Anyway, let's now get on with the video. So when you look at this stand, it is a little bit unstable, but it's only when you look a little bit more closely that it's really weird. That it's held up by 3 strings that are in tension, and there are no legs, there's nothing in compression. Yeah, it wiggles around a bit, and in fact the one that I'm going to build today is much more stable than this. The other thing about it, which took me a long time to think out, is in fact if you tip it upside down, it doesn't work at all. So I'll let you think about why that is. So with all of this in mind, I thought I'd build a big example of this, and perhaps I could use it in the garden as a table or just a flower pot stand or something. And actually, jumping ahead, we had some friends over for tea in the garden the other day, and I thought, well, I'll set this table up and say nothing about it. And I actually put the tea and coffee on it and all our best china, and it was slightly wobbly, but it stayed up absolutely fine. And the guests actually went and got themselves some tea and coffee without me having to serve it. And do you know what? They didn't make any comment at all about the unusual table. Well, I've convinced myself that if something works really, really well, you don't notice it. As you may be aware, most of my projects seem to be complete money pits, even if they're really simple ones, and use far too much of my hard-earned coin. So I was walking past the skip a while back, and you might have seen this from my video on the harmonograph, and I saw in it some wooden chair legs. And using the sculptor's maxim, always pick a piece of stone or wood that looks a bit like the thing you want to make, I hauled out these chair legs, and straight away I looked at them and I thought, these are going to make an absolutely brilliant tensegrity demo. So let me do a quick drawing to explain how this is going to work and what we're going to make. So here's the tabletop, and forgive me if my drawing is not brilliant at the moment. I'm sort of kind of working around the camera and not using a ruler. There we go, or a rule, I should say that, shouldn't I? So there we go, and here's the base. Good skill, by the way, if you're a teacher. You probably wouldn't want me to do it, looking at this, but teach your kids to draw diagrams like this. They're really helpful later on in life. Okay, and then under here, we're going to fix our curved chair leg that I pulled out the skip. And here's the other one. It goes around like that and mounts onto here. And then we're going to have a fine wire between those two. And that, of course, will collapse. But you can imagine that if there was a weight on here exactly on the centre of mass, that would balance. And then what we're going to do is add a wire down here to this corner and add another wire down here. Oh, I think I got away with that. To that corner. Now, when you look at this, it looks really weird and a little bit odd, but you have to think about it, that if you press down on here, isn't this turning into one of those, do you remember the Open University black and white films on BBC Two back in the day? Chap with a pencil pointing at stuff. Anyway, if you push down on here, it won't collapse because these two will be in tension and this will be in tension as well. Now you might say, well, okay, what happens if you push down on this corner? Well, you'll be surprised because if you push down on that corner, this is still in tension and this will be in further tension, stopping the back corner, as you look at it, tipping upwards. So you might say, oh, well, there are places you can put weight on here and it will fall over. But I think you'll be surprised just how stable it actually is. So, not a brilliant drawing, so we better build the real thing so you see how it actually works. I started by selecting 4 of the legs that seemed suitable for the build. The weather was uncharacteristically hot, so much so that I had to move the workbench into the shade. I set to cleaning the legs up a bit. It makes a change as a teacher scraping off glue rather than chewing gum. The chisel and mallet were my father's, so probably close to 100 years old. Those old chisels remain razor sharp, a testament to the steel, probably from Sheffield, that these were made of. I then screwed the legs together in the shape that I wanted as a precursor to long bolts arriving, as I didn't have any in stock at the time. I had an old pallet knocking around that I cut down to a more manageable size, and I decided this would make an excellent base for the project. Drilling through the lower leg set, I did find some M6 bolts of the right length that I happened to have in stock. As an aside, and without being too morbid, I am not getting any younger, so I'm trying to consciously run down some of my stock, as I have no idea of what its future would be otherwise, especially if Barry doesn't follow in my footsteps. I think that's one for the comments below, I'm sure. With the arrival of more bolts, I bolted the old chair legs together, as they do need to be fairly strongly attached. I left the screws in anyway, as there was no need to remove them, and they added to the strength. I didn't use any glue, so it can be repaired or taken apart if necessary, or if it's no longer wanted. For the top of the Tensegrity table, the only large flat area piece of wood I had was an unused IKEA shelf. So I set to cutting this to the right shape, as well as removing the ends that had metal shelf supports on them. As I was not following any technical drawings, but just making it up as I went along, I thought at this stage, therefore, I would do a test to see if it all worked. I realised it would not be very strong, but I used some metal screw-in eyes and green garden twine. Having screwed the top to the upper leg, I tentatively put it together, holding it together with the garden twine. Firstly, the twine broke, and then the upper leg pulled out of the top as the screws were not in very far. So I decided to drill through and put in some 4mm bolts as a temporary measure and try it again. A lack of hands made it particularly difficult to string together, but with a bit of time and effort, I finally got there and was able to give it a try. I was not at all sure if it would hold together, But with Barry keeping an eye on the health and safety, I gingerly lifted up the top and swung it round into position. And it worked. I must say I was truly astounded that it worked so well. Perhaps I should not have been, but I really felt it would need lots of adjustment, but it worked first time. It was then that something strange happened, and you, I hope, will experience the same feelings as I did. It was such an amazing and incongruous device. I found myself just staring at it from all sorts of angles for about the next 15 minutes and probably longer. It really does seem to defy logic in every way. I learned quite a bit about myself from this, so forgive me if this turns into FJ the life coach for a minute or two. Even though I consider myself to be pretty resilient, I'd had a pretty poor day, taken up with admin and dull house clearing and the like. This build was not going too well either, and I had to replace the screws in the top with bolts, but when I tried it out for the first time and it just worked beautifully, I was so surprised that it completely turned my mood around. It shows that just a little bit of success can go a long way to turning your mental state around. And anyone who happened to come anywhere near me for the next hour or so, including my partner's work colleague who dropped her off at home, had to be invited in to see the marvel that stood in my garden. There's a fine line between enthusiasm and arrogance, but I think in this case I was the right side of the line. So, with success in the bag, it was now time to finish it off by doing away with the garden twine and replacing that with some thin and shiny stainless steel wire. I didn't have any prior experience working with steel wire and fixings like this, so it took me an age to plan what fixings I might need that weren't also going to be exorbitantly expensive. After visiting a local hardware shop that was intrigued by what I wanted to build, in the end I had to go to the online retailers that had what I needed, some of it only available from China. The 1mm stainless steel wire was from a UK fishing supplies shop. I guess it's used if you have a fish that's going to bite through your tackle. I think I'll stick to inanimate objects, though I have had the odd nip from a pair of pliers before now, and it's always the same pair that do it, usually those mole grips. After a lot of thought, I realised I could use some M5 turnbuckles, which were not only cheap, but if pulled apart would provide suitable hooks and eyes for the project. Having drilled the holes for them, I found that the hooks were a bit shorter than the eyes and would not accept an M5 nut. After being mystified for a bit, I realised they were of course left-hand threads and need a nut and thread to match. So I ordered up some M5 left-hand thread nuts and finished off the fitting of the hooks taken from the turnbuckles. This would allow me to pull off the support wires more easily when I wanted to collapse the table, as it was rather large to store in the garage as it was. I could now begin to build the all-important tension supports between the base and the top of the table. It was important that I got the upper chair legs in the right place, so the short section of tension wire would be fairly well positioned to enable it all to be stable. In the end, I managed to find some ferrules of the right size with a crimping tool that was actually quite cheap, so I set to making the remaining wire supports, which were clearly going to be stronger than the garden twine I tested it with earlier. It was a fiddly process with the wire being only 1mm in diameter, but it was actually quite satisfying to do, and even though I've not done this before, the end result was pleasing, as I hope you'll agree. With the wire ropes manufactured, it only remained to string it all together and then raise it up, make a few small adjustments to the wire lengths and then marvel at the structure that I built. Possibly it looked better with the garden twine, but I felt it was worth making the wire supports to give it some strength and to make it look a little less rustic than it already did. All in all, I was really pleased with what I'd made and I enjoyed the build process. It's now clearly a template for others I might wish to make in the future, possibly smaller and out of rather nicer wood overall. Oh, just before we finish, I thought I'd show you this. I was sketching some drawings for you last night to try and explain what was happening. And as a teacher, the more you draw things, the better you understand it. And you think, okay, I can explain this really well. And instead of using a top and a bottom and these curved, what I call chair legs, I actually just drew the chair leg shape twice, the curved bit, and then made it into a sort of 3D shape. And I suddenly thought, wow, that hasn't got the bottom and the top part. They're sort of built in, as it were. They're integral. So in many ways it's sort of similar, but not quite the same. And I gave some thought to what I might have to put here, maybe one wire in the middle or maybe one on either side. But that's a shape and design I've not seen before. So perhaps I've invented my own design. Maybe not, maybe it's been done before, but I thought it was really interesting, and I really think I'm going to have to make one of these very soon. So that was a really fun build. Why don't you have a go yourself building one? I think it lends itself perfectly to 3D printing, and you don't have to use steel wire. I think you could use very thin nylon fishing line or something like that. If you do build one, please let me know how you get on. I just think it's a real shame that YouTube don't allow photographs in the comments, but at least you can write to me and say, I built one of these and this is how it worked. So thanks very much for joining me again in the home lab today, and I hope you really enjoyed that project and perhaps saw something that you've not seen before. As ever, do please leave comments. I really enjoy your comments, and quite often I learn things that I didn't know before, or life experiences that you've had that are really interesting and add to the story. And I think it's quite unusual on YouTube actually to have comments that add to the videos. You could say that's because my videos are no good, but certainly with the electronics ones, I've been really interested in things you've had to say. Also remember, at the end of the video, do please stay until the very end, because I put a few links to other things there that might interest you that you might not have seen. Anyway, I'll be making another video soon, so please do join me then.